This is David Thiessen with PrairieLand Partners, and we'd like to share with you the PrairieLand Advantage and the 600 Series Rigid and Flex Headers optimization. First off, we'll be looking at maintenance, cutter bar, reel adjustments and optimization with the auger to help you maximize your performance of the header. If the header is not set right, it will affect the machine's performance and create lack of efficiencies behind the header. Also want to remind you that we do have out there on our PrairieLand Partners website, the video section. We have a place for you to go take a look at daily maintenance videos for the 600 series header. So I will not cover much about the maintenance of the daily maintenance on it. I will be more focused on optimization and getting the header set right for your machine to meet its performance. First off, we'd like to remind you about safety and observe all the operator manual safety warnings. And also, when you have the header hung on the combine, make sure that you have the lower latch pins set in. And if you're working underneath or around it when it's going to be off the ground, please set the cylinder safety stop as shown here in illustration A. One of the other things that we want to remind you about on the 600 series header is that it's all driven off the left-hand end of the header. So with that said, if you happen to be turning the auger while you're trying to work on the sickle or leaning against the guards on the sickle and turning on the auger, the sickle is going to move back and forth. So we really advise you to take off the knife drive belt so the knife drive and the auger are not tied together, and that will prevent potential injury. One of the key things that we see in daily maintenance that is maybe overlooked or not thought about often enough, and it affects wear of the guards and the sickle sections and knife drive load that it takes to cut the crop, and the cleanliness of the cutting of the crop to keep the machine capacity, and that is maintaining this air gap between the guard and the sickle section. Ideally, we would take the sickle section and hold it down with our one hand against the guards, so the sickle section is touching the guard, and then we would measure the air gap between the hold down and the sickle section to verify where it's at and make adjustments from there. As you can see, we want about a 20,000th of an inch, or equivalent to what a business card thickness would be. When I get done adjusting it and doing my daily maintenance, I would prefer that we would go ahead and start the machine up with no bystanders nearby, run the combine and the header together for a few minutes, and then shut the machine down, shut the engine off, and go by and double check each hold down to make sure it wasn't getting too hot during that run-in. I expect them to run warm, but if we're running too hot, that could be detrimental to in-crop experience, and also we're creating wear and binding that's going to affect the life of the cutter bar and the wearability of the hold downs. Worn guards. A lot of times we take a look at customers' headers and have a knife drive complaint, or something's not performing well enough and not cutting crisp enough, and we find that the center of the divided 4-inch sickle guard on a 600 series header type cutting system, the center one is the dull one. And so we've got an example here on the left. We have the nice sharp crisp edge with a guard that has the cutting mechanism that goes back over the top to help hold that sickle. And then in the center here, that center yellow circle, you can see that center point is started to round off. And that's a lot of times where we need to look first before we start looking at the outer edges of that guard and see what our center point looks like. If it's getting round off or domed off, we're not cutting anymore. We're going to be pinching, and that's just going to cause undue strain and load on our knife drive and probably cause a failure down the road. There are two types of guards available for your 600 series type headers. Let's start off with the black guards. The black guards are just a common standard wear. They're made softer material, and they are made more for rocky conditions where we might typically have a point where we want to have the guard bend instead of break. The wearability is not going to be there like we probably would expect. The green guards, as it says here, is the high wear, and they're the best value, and they are double heat treated for wear life, so they hold up real well. This is just another example of the green guard and the 4-inch blunt point guards that you find on most flex headers. That would be the ideal setup for running flex headers because it's a short, stubby guard that runs well on the ground and is designed with a double hardness like we talked about for wearability. If you're running in no-till conditions and you have previous year's corn stalks or something large that maybe has a hard time entering into the header, These can be utilized along with a sickle section that we'll talk about here, but they do have the crossbar just behind the knife cutting area to help give that strength and guide that sickle bar as we push and pull that sickle bar through its stroke. The 4-inch long point guard is a standard guard on rigid platforms, and it's used to comb through small grains and fine stem crops. And it's preferably used in only small grains, but it provides a nice combing action. It's an excellent guard, but in typical soybeans and maybe some weedy crops, it might want to stab the crop versus comb through it. But it will do a nice, even, effective, clean cut on a rigid type platform is where we prefer to use it. Then there's a 4-inch no-till blunt point guard, which is be like on the flex headers, except this one here you can see has no crossbar behind the cutting mechanism, and the center point is a little farther back for its cutting action. This is a guard that allows the crop material of those large corn stalks or previous sunflower stalks when you're cutting on the ground, maybe with soybeans, to engage the knife and become cut real evenly and effectively. Sometimes in no-till situations, we have the point where the guard is the limiting factor, and the sickle, as fast as it runs up there with its twin knife, will cause the stalk not to enter into the guard and cut. And then it just gets pushed down, and it pushes also the good crop that we're wanting to maintain getting in the header. It'll push it down and push it underneath. If you get into that situation, there are options available at the parts counter when you need some other types of options. Often we find when we go out to operations and take a look at cutter bar complaints or not getting a good clean cut on the sickle, what's going on is we find between the guards and the sickle sections is our limiting factor or affecting the machine capacity. As you can see in this representative photo, on the left we have a blue circle, and you'll see there some of the tips are broke off that sickle section. That's a good example of when to replace them. And then on the right hand side you see the red circle, and those tips are all broke off. And if you looked at the edge of that sickle section, you would find that that's more of a blunt point than it is a sharp, crisp cutting edge, which will create binding and pinching and just increase the knife drive load and also affect the cutability at some of the speeds that we try to harvest at. Knife drive end on the left-hand end has the knife drive head on a 600 series header on an elliptical knife drive where we push the cutter bar back and forth in a straight parallel line. And inside there is a composite white ring. We find often that maybe the composite white ring has been run too long or not replaced when the sickle bar was replaced and updated. With that, we want to make sure that we're replacing the composite ring. That composite ring is designed that when the head of the sickle is clamped down with that bolt 11, that composite ring holds a nice, steady, firm squeeze on that bearing, but it doesn't crush the bearing and cause the bearing on the knife drive cutter head end to fail. We also want to remind you that we need to torque that number 11 bolt to 96 foot-pounds. Sometimes we over tighten it or we don't tighten it enough, and then we have a knife drive cutter head failure that happens from that. Here's examples of our 4-inch Dura twin knife sections. We have 7 teeth per inch sickle sections, or we have the 14 teeth per inch sickle sections. If you were going into a small grain type crop, a wheat harvest or canola or something like that, I'd really encourage you to take a look at changing and having 2 sickles, one for the 14 teeth per inch sickle, and then another one for the fall at a 7 teeth per inch, just because of the coarseness of that sickle. We have seen and had examples several times where customers maybe had knife drive belt failures or were complaining about the cut quality in fine stemmed crops like wheat, or even sometimes double crop soybeans and wheat stubble in the fall when it's damp, that stubble, and or we've got green volunteer growth coming back through and we don't have the cut quality that we'd like. And that is because the 7 teeth per inch is a coarser tooth and it doesn't cut as quick and as clean and as neat. And if we run a Dura Twin 14 teeth per inch sickle section, which is a fine cut sickle, we reduce the load that it takes to cut through small grains. And in small grains, especially with fungicides and some of the growth regulators that we add throughout the season, those all affect the cutting ability of that crop, and the quality of the guard and the sickle have to be in excellent condition, especially at the starting of wheat harvest when we have a lot of typical green stems and tougher straw material that we're going to be working through. There is also the short long knife sections that go along with that open type guard that we talked about earlier. This Dura Twin short and long knife section is designed again to help those larger stalks get back farther in to the guard, so we do a good job of cutting off previous crop year corn stalks, sunflower stalks. Maybe we've got a weedy condition and the weeds are fighting us a little bit. This would be one of those options that we'd want to take a look at. And again, we offer 7 teeth per inch or 14 teeth per inch fine cut sickles, and I would look at it the same way using the 14 teeth per inch in my small grain type applications. Many of you have become accustomed and used to the lightning bolt sectionalized knives that we have bolt together 9-foot sections. So if you go to the parts department and are wanting to replace a sickle before harvest, you'll get those in sections, and it takes a hardware kit to assemble it. One thing I wanted to talk about here also is that bar that the sickle sections mount to. Sometimes we keep replacing sickle sections and we don't pull the bar out and flip it over and evaluate what our bar actually looks like. And then we cause ourselves the potential of an infield breakdown with a knife bar that's not worth rebuilding. So I'd take a little time before we start into small grain harvest or even in fall harvest this fall and look at that bar and evaluate how much wear has happened on the sides and see if it's worthy of cutting again on another harvest. If you do have the cutter bar break out in the field because of a foreign object or the cutter bar was not in good condition, they do have these knife back repair kits that are a quick, easy, simple fix out in the field. And I'd encourage to keep those in your combine cab or a toolbox nearby in case you do have a failure out in the field and don't have to have a welder, then you can make a quick repair right on the machine. Next, let's talk about optimizing our auger. And first off, we want to match the header to the combine, and then we'll talk about some auger height and finger timing settings. Many times we've bought a header that's not maybe set correctly for our machine that we're wanting to hang it on. This is an example of a 9600 combine, and a 9600 combine uses a full width feeder house. So the full width of the opening of the header is going to be utilized versus the STS or the 9500s have the same width feeder house, what we call a narrow type feeder house. And let's discuss what we need to look at for auger rear strippers and also our floor strippers, making them match the width of our feeder house. So we utilize the capacity of our Walker and STS machines. First off, the thing I would want to do is take a look at when I'd hook up to the combine. Look at how my rear of my header is open to the feeder house opening with those rear auger strippers and the floor strippers. As represented here in illustration number 1, you see A and B are our auger rear stripper and our one floor stripper. And we want to make sure that that matches the width of our feeder house opening. If it doesn't, then we've either got to unbolt it and move it out or unbolt it and move it in. So we make sure that we're feeding the width of that feeder house and using the full effect of our combine. The other thing we need to take a look at is in illustration 2 is how our auger is set up for our feeder house width also. You can see in illustration 2, we want to check to make sure that our auger flighting comes to the edge of the feeder house but not too far in. And if we have an STS type machine, we'll want to pull it in farther to the center because of the narrow feeder house, or a 9500 type Walker machine. Here's that rear auger stripper that we're talking about. The feeder house opening angle iron width of that feeder house would be to our right there, and then in that red circle would be the rear auger stripper that needs to match the feeder house opening that we have. And that can be unbolted and moved to the left or to the right with bolt holes in the floor and off the top strap iron that is our adjustable auger stripper. Here's an example of our auger flighting extensions, and we need to make sure that they match the width of our feeder house. And sometimes we need to lay out just a little bit more in front of the feeder house so the feeder house conveyor chain has a better chance of grabbing the crop and pulling it away from the header versus having that delay in there. On the STS machines with a narrow feeder house or a 9500 type machine with a narrower feeder house, you can see that we want to put one set of flighting auger extensions on from the factory original. Well, how do I know if I've got them on or not? Your end of your factory original auger flighting that's welded to the auger tube has 2 square carriage head bolt holes in the flighting. And the first extension would be bolted in with bolts H from there. And then we'd add the bracket G as the cast iron bracket or an angle iron bracket that holds that auger flighting extension in place. And that first wrap that you see there, F, with a darker color, would be what I would want to lay out the crop material in front of my STS or my 9500 combines. When we do that, though, we have to remove two of the retractable fingers in that red circle and put a cap over it so we don't have any crop material pushing towards the feeder house before it's ready to go in the opening. Next, let's talk about floor strippers. With the floor strippers, we want to take a look at the condition of our floor strippers and see how much wear maybe is on that front lip, like B in the illustration's pointing towards. And also, some of the early 600 series headers did not have D as a second floor stripper. And when we're in small grain conditions or maybe double crop soybeans and wheat stubble, and we have that material flow coming across there, and then all of a sudden there's a bouquet of crop material that wants to come up from behind the auger before it gets to the feeder house and gets pulled in, it can be limited. And we can prevent that by adding the second floor stripper as representative in this illustration of D. Adjusting that auger height to that floor stripper is another way to help also maintain that crop engagement, so we make sure that our full finger augers are pulling that crop evenly along underneath and pulling it to the width of the feeder house before it releases to the feeder house. As you can see here in image 2, on the right hand upper corner, we have how those adjustments are made. And then also in image 1 there on our left, just wanted to make sure that you loosen your chain before we go to making these adjustments, because we're going to be affecting how the chain tension's set on that. And then when we're done making these auger fore and aft adjustments, make sure that we go back and readjust our auger drive chain. So here's an example of how we would like to set the auger to the stripper adjustments. As you can see, we want to maintain about 7/16 of an inch from the floor with A and B in this illustration. And then we would like to, ideally, if we can, at C and D, maintain an 1/8 inch, but that's only if the auger runs true enough. Many times we find augers that have been running in a lot of harsh conditions where maybe we've had some slugs happening from the crop material flow and they don't run as true. Or an auger sometimes, when you park it in the sunshine, will pull towards the sun and start to run out around. And sometimes we can't check an auger unless it's been setting in the shade before we make these adjustments. A lot of times we can't adjust them down to an 1/8 inch. If you can get it to quit rubbing and stay within about an 1/8 inch of the flighting on those strippers when you're all said and done, that would be ideal. But the outer roundness of the auger typically determines how much adjustment and where we can set it. At the bottom there, you can see another side note is that make sure that we adjust to maintain 5/8 of an inch clearance between the center auger fingers and the floor of our header. That way we don't have the auger retractable fingers hitting our floor and breaking off fingers or damaging our auger floor. During those adjustments, I want to remind everybody that that adjusting rod that's there behind the drive sprocket on the left-hand side of the drive chain, or on the right-hand side, you'd have the same type of mounting for that auger adjustment rod up and down of the auger. We do not want to tighten it. In that red circle on the right, you can see example of how we should keep it just slightly loose. If we try to tighten those two locking nuts so we've squeezed that bracket in the rod tight, then that rod has no flexibility and the rod starts to flex and breaks that rod off into threads. So just an example and a reminder that we want to leave a little bit of an air gap so that rod has some flexibility as that auger tries to move around on its pivot point. Auger finger timing, something we want to make sure of before we go to the field that's still working right. And as you can see in the right hand photo, from the right hand end of the header, we want it to be pointing at the 3 o'clock position and it should be fully extended. As that auger comes around and pushes the crop towards the feeder house, we want those fingers to retract and be flush at the back, pointing towards the feeder house drum. That way we get a good, nice crop transition and release as we hand it off to the feeder house without a delay. And it helps prevent the crop from coming back around on the back side of the header and fluffing in front of the feeder house after we've compressed it and pushed it down. To do that, you can see on the left illustration how to adjust that with your finger auger timing on a 600 series header on the right hand end of the header. But again, we want to make sure that you realize and also pay attention to avoid damaging your floor, that you maintain that 5/8 of an inch clearance between your retractable fingers and the floor so we don't cause ourselves damage to the floor or the fingers. Let's talk just a little bit about reel optimization settings. And one thing first off here in this red box that I wanted to talk about is making sure that we have our reel timing on the right hand and the left hand end of the header engaged in the same pinhole. Sometimes we go out to help a customer get set up and get going on a startup, and the reel maybe isn't engaged in the same timing pins, and that puts a twist on those pipes, which increases the cam bearing wear points, and also the reel pipe wears into those bearings and those bushings and creates a higher wear situation. The other thing we want to talk about here is how our reel fingers are engaging and entering the crop. Ideally, we would come into the crop vertically as straight down as much as we can and just make a nice sweeping action as we come across the cutter bar without fluffing or kicking up the reel fingers towards the auger, so we don't fluff or kick up the cut end of the crop as we deliver it to the auger. We want to keep it as much as we can evenly and smoothly as we can transition off that cutter bar into the auger to help the machine's capacity and the auger's capacity. Crop dividers. From the factory, your headers would have come with these long floating type crop divider points. And you've probably noticed if you wiggle the steering wheel a little bit, you'll lay down crop that's not been cut and potentially can't get it stood back up. We've found a lot better option with these shorter floating type crop dividers. On the left is a nice example, or in the center illustration. Those are shorter, so as you wiggle the steering wheel or make a contour cut, you're going to have less crop that you're going to run down. And you can stop by your PrairieLand Partners parts department and take a look at this example and see what would work best on your farm. Reel positioning. On a flex header with an auger type platform, it is critical how that reel hands off from the cutter bar to the auger, because we have that dead zone between the cutter bar and the auger. And a lot of times that's a challenge in shorter crops and shorter material. If we don't have the transition and the flow down and back to help that reel hand off to the auger, we create a delay or a bunching that affects the machine's performance. The flex headers, as you can see, that's live with that belt running towards the feeder house behind the cutter bar. And that's with the effectiveness and the efficiencies that we gain when we run a flex draper header in soybeans or in wheat and small grains. Let's talk a little bit about reel settings and setting the reel height. First off, we want to maintain a minimum of 2 11/16 between the reel pipe and the auger center fingers, the retractable fingers. We can set that reel in a different fore and aft position than the pinholes and pull it back too far and cause the reel pipes and the auger fingers to clash and bend the reel up or break fingers off. The other one is we want to maintain our pickup reel fingers to a clearance of at least 1.5 between the reel fingers and the cutter bar. And that's done by leaving it in a flex mode position, putting like a 4x4 or a 6x6 wood block on the ground and setting that header down on it and pushing it up all the way into a flex mode that it can go. Then taking and measuring between the reel fingers and the cutter bar to see if we're at least maintaining a 1.5 inch. Sometimes when we're out in rougher conditions, a reel will have a bounce and we might want to go more than that 1.5 inches. We might want to put it at 2 inches, but if we're not close enough to the cutter bar in certain conditions, we don't do that clean sweep as we move that crop across there, and it delays the performance getting it to the auger, causing some of our bunching problems. With that reel fore and aft lift cylinders, here's some course adjustment settings. The one on the left is our fore and aft cylinder, and as you can see, it's pinned in that center hole. That's an ideal position that we can keep our reel from getting close to our center retractable auger fingers like we just talked about. If we were to go to the front hole, we would pull that reel right into our auger and damage our reel and our auger. So take a look at that so we don't have a situation and you're moving the reel fore and aft back and forth and cause it to get into the auger. The other one is we can do reel raise and lower adjustments with those side pins that hold the cylinder positioning if we don't have enough thread on our reel height adjustment. Pickup finger reel pitch. We talked about this earlier, but this is just another reminder to make sure that we're pinning it in the same engaged position on the timing on the left hand and right hand end of the header, and that our reel fingers, when they come down, they are going vertically into the crop and moving that crop across the cutter bar in a sweeping motion and not fluffing up the butt end or the cut end of the crop, so our reel hands it off to the auger as smooth and seamless as we can. Reel speed sensors for dial speeds. Before I went to the harvest field, I'd encourage you to take the reel drive shields off the right hand end and let's check our magnetic tone wheel speed sensor and our tone wheel to make sure that everything's in good condition. What a lot of times we find when we take that shield off is that's a metal on metal cast iron gear that runs for many, many hours and gives good performance, but the metal on metal causes a exchange of fuzzy metallic material to wear off. And that fuzzy metallic material will stick onto our sensor for the dial speed wheel speed. And when we get that metal fuzz built up too much on our magnet, we lose the effectiveness of our dial-a-speed system being able to read back to the cab and tell it what we've got for a real speed, and we lose the effectiveness of our dial-a-speed. So just removing that shield every once in a while, double checking that magnet for fuzz buildups on there. If it's got much on there, just wipe it off with a finger or a rag. And then also, while we're there, I'd like to check to see if our magnetic sensor is close enough to the tone wheel. Well, how do we do that? Well, here on example number 2, we undo the lock nuts and we'll turn that sensor in until it touches the tone wheel, and we'll back it off a half a turn. And then I'd like to roll the reel by hand and watch that my tone wheel and that magnetic sensor don't interfere with each other, and then tighten the locking nuts from there. Maybe some of you have experienced this with your 600 series auger or flex drapers, and that is reel wrapping. When we have tall green stems like soybeans or sometimes other crops, we have a tendency to want to wrap crop material around our reel pipes. And there is flip over kits that you can get at your PrairieLand Partners parts department that are available to flip that reel as it comes over, and that prevents this wrapping from happening around those reel arms. We've been seeing this to be a very effective and very handy way of taking care of that. Sometimes we get into short crop or thin crop, and we have a hard time on an auger header getting the crop material to flow from the cutter bar to the auger. And one way that we've had a lot of good response from is using these wide reel fingers. These wide reel fingers, as you can see in the left-hand illustration, slide up over your existing reel fingers and they snap on that web across the top. And what we've seen is you don't have to put them on every finger. You would maybe put them a foot or two apart and then stagger them across the reel rotation around the reel as you put them on. And doing that, that just helps that crop engagement come across that cutter bar, sweep it off, and hand it to the auger so much more effective. And it helps in those short crops or thin crops if you've struggled with that. Let's talk about preparing your flex headers for small grain harvest and the off-ground height sensors that can swing down from underneath the header. Here's an example of that sensor. Not all headers had it, and if you ever want to, we can add something on the existing header if you don't have these on yours. They are extendable, as you can see on this green bracket coming down, and where the box sensor unlocked points towards, there's 2 bolts there. And those 2 bolts, when you remove them, you can slide in and slide out the composite finger sensor for height of cut that you're desiring if you can't adjust it from the cab with your exact cut height. When we're doing that, we also need to remind you on your flex headers to lock up your cutter bar flex. But before we do that, we want to calibrate the whole header with those off-ground height sensors and the flex header sensors together all at one time. And then we lock up the cutter bar so we're in rigid mode with these brackets. That wraps up our 600 series auger header. Want to encourage you again to think about going out to our PrairieLand Partners website and looking at our videos. And that's how PrairieLand Partners delivers the right solution. Thank you.